After 2 months, we have wrapped up chapter 9. We're now going to move on to chapter 11. We will come back and take a look at chapter 10 a little bit later. But for now, we're going to focus on 11.2 and 11.3 on radicals. There's a lot of material contained in both those sections, so we're going to take our time. Today, we're just going to learn one rule and one property. So right here at the top, we have radical 20, an example of a radical expression. Note the difference between an expression and an equation. We will look at some equations in 11.3. So this represents the square root of 20. Now, the reason we're going to look at radical expressions, we know that the square root of, say, 16 is 4. We know that the square root of 9 is 3. But we're going to focus on how to simplify an expression like radical 20. If you put the square root of 20 into your calculator, you get a long answer with a lot of decimal places. So we'll show you how to leave it in a simplified form. You heard me refer to it as radical 20. You can also refer to this as root 20. I would probably use those interchangeably. Either one is an acceptable way to say this. One more quick note that I don't have on the whiteboard here. 20 in this case, the number itself is what we call the radicand, R-A-D-I-C-A-N-D, and you have just your radical sign right here. This is a square root. There are such things as cube roots and fourth roots. We're not going to look at that in Algebra 1, more on that in Algebra 2. So let's go over our rule. Rule number 1 says that for radical expressions, there are no perfect square factors allowed in the radicand. So this root 20 is not simplified. So your perfect square factors. Over here on the right is a list of the perfect square factors I would expect you guys to know for Algebra 1. We go from 1 all the way up to 144, which is the square of 12. Obviously, it goes beyond 144, but I'd say for our course, you should feel comfortable knowing these numbers, recognizing them as examples of perfect squares of the numbers 1 to 12, obviously going in sequence right here. So we're going to show you how to simplify radical 20, and we'll do one more additional example. To do that, we're going to use the product property. The product property tells me that the square root of a times b can be simplified into the square root of a times the square root of b. So we're able to break a number up into two factors and then potentially simplify that into a new expression. So let's do that. Radical 20. So we're going to think of the perfect square factors of 20. Let's think of all the factors of 20. We know we have 1 and 20, no perfect squares. We have 2 and 10, no perfect squares. The other pair of factors for 20 is 4 and 5. So I'm going to represent root 20 as root 4 and root 5. Notice that I put the perfect square of 4 in front of square root of 5. Since 5 is a prime number, has no more factors, that's going to be simplified. But what I know about root 4 is that the square root of 4 is 2. So all I need to do here is simplify this, make it 2 radical 5. And we check, since root 5, like I said, prime number, doesn't have any more perfect square factors, that is simplified. So your final answer is 2 root 5. That is the simplified form of square root of 20. Let's do one more while I have space on the board. Let's simplify radical 48. So again, we want to think of our perfect square factors, which I have up here. And since we just used square root of 4, that's something you might think of here too. So let's break this down into square root 4, square root 12. That's the other factor of 48 that goes along with 4. So I'm going to say root 48 equals root 4 root 12. And we know that root 4 is equivalent to 2. Is this simplified? Well, let's take a look at square root 12, and it's not a prime number, and it does have a perfect square factor. In fact, I can factor out root 4 again. So I need to keep my 2 in place here, and I'm going to make root 12 into root 4, root 3, keep 2. Root 4 is equivalent to 2, so these are going to multiply. Everything right here is multiplication. 2 times 2, root 3. Prime number, no perfect square factors. So the final simplification of root 48 is 4 root 3. Now some of you were probably watching this and pulling your hair out saying, Mr. Kane, there's a much easier way to simplify this one. since you don't have to take the best perfect square, but it may make your problem a little bit easier. So if we go back up to our list of perfect squares here, 48 also has a factor of 16. So what I could have done to make this problem a little bit easier for myself is say that root 48 could have been root 16, root 3, and in just 2 steps, I have that final answer, which took me several more steps in the previous way of doing it. So my point of showing that is you can come to the correct answer by taking multiple perfect squares, but sometimes you might want to look for the best one. So look beyond just 4 or 9. You may want to try 16, you may want to try 36, 81. See if any of those are perfect square factors of a number before going on.